Alright, this last one that I'm going to talk to you about has to do with subtracting mixed numbers. So mixed numbers, as we learned previously, is actually the combination of wholes and parts of wholes. And a mixed number is actually a shorthand notation of writing the addition of two fractions, the addition of a whole and the addition of a part of a whole. Okay, so we're subtracting mixed numbers, and the first step in subtracting mixed numbers is to rewrite the mixed number as an improper fraction. And once you've done that, then you can use the subtracting fractions algorithm. Alright, so we have a mixed number. We have 3 1/4 minus 1 2/3. And the first step is to rewrite this mixed number as an improper fraction. So the way we do that is we can assume that we're going to multiply 4 times 3, which is going to be 12, and we're going to add that to 1. So that's the algorithm for changing a mixed number to an improper fraction. Multiply the denominator and the whole number, and then add that product to the numerator, and the answer you get becomes your new numerator all over the sequence of fourths, your denominator. Whatever case your denominator is, that will always stay the same. So 4 times 3 is 12, plus 1 is 13. 13 in the sequence of fourths, minus 3 times 1 is 3, plus 2 is 5, all in the sequence of thirds, equals, now if they had the same denominator, we could simply subtract and keep the denominator the same, because we're talking about the same sequence. But we're not in the same sequence. This is in the sequence of fourths, this is in the sequence of thirds. So we first have to use the subtracting fractions algorithm to come up with a common sequence. So we have 13 times not 3 is 39, minus 4 times 5 is 20, all over 4 times 3, which is 12. I'm going to set that equal to the denominator of twelfths, and 39 minus 20 twelfths is going to give us 19 twelfths. And the way that we can think about this in terms of looking at the answer, we know that the numerator is greater than the denominator. So therefore I know that I'm going to have some amount of wholes and some part left over, some remainder. So therefore I'm going to see how many twelfths does it take to make one whole. Well, if they're twelfths, then it's going to take 12 twelfths to make one whole, because 12 divided by 12 is one whole. Therefore, how many wholes can I actually get out of 19 twelfths? Well, I can take out one set of 12 twelfths, and that means that I only have one whole. And I have 7 twelfths remaining after that. Therefore, 1 times 12 twelfths is going to give me 1 times 1, because 12 divided by 12 is 1. And 1 plus 7 twelfths is the same as 1 and 7 twelfths, because and means to add. Okay? And if you didn't want to think about it in this way, you could do it the other way. You can take your numerator and you can divide it by your denominator, and you can see that 12 goes into 19 only one time. 1 times 12 is 12. 19 minus 12 is 7. And as we rewrite, we know that we look up in the quotient for the whole number, we look down at the remainder for the numerator, and we look to the right, to the left, for our denominator in the sequence of twelfths. You can think of it like a golf swing. You're getting ready to pick your golf club up, then you're putting it down, and then you're swinging to the denominator. That's just one way to think about it. Okay, let's go to the next one. We're going to try this one together. First step, I see mixed numbers. I'm subtracting. Therefore, I have to change them to improper fractions. All right, let's do that. 4 times 7 is 28, plus 3 is 31. 31 in the sequence of fourths, 31 copies of fourths, minus 5 times 3 is 15. 15 plus 4 is 19. 19 copies of fifths. Now, do they have the same denominator? No. I only have to worry about the same denominator or the same sequence if I'm talking about adding or subtracting, because they have to be on the same number line. But they're not, so I have to symbolically represent them on the same number line. I can do that using the FFFP. Alright, let's go for it. 31 times 5, let's do that off to the side. Is 155. Subtract that from 19 minus 4. Sorry, 19 times 4. You get 76. All in the sequence of 20ths, because 4 times 5. Alright, let's perform some subtraction now. 155 minus 76. I have 15, borrow 1 from the 5. Borrow. Okay, here we go. 15 minus 6, 9, and 14 minus 7, 7. Answer is 79 20ths. And how many 20ths does it take to make a whole? I know that my numerator is greater than my denominator, so I know that I'm going to have a mixed number. Therefore, 20 20ths. If I see 20 20ths, 40 20ths, 60 20ths, 80 20ths is too much, so I'm going to go back one. I have 3 copies of 20 20ths. That gives me 60 20ths, and how many do I have remaining? I have 19 20ths left. So this is going to tell me how many wholes I have, which is 3, and 19 20ths. And the abbreviated form of this is to write 3 and 19 20ths, replacing the addition sign with just the word "and" when you say it. So 3 and 19 20ths is my answer. If you wanted to do it the other way, by dividing 79 by 20, you get the same exact thing. How many multiples of 20 go into 79 without going over? 3 of them. We get to 60, and we have 19 remaining. And the answer is 3 and 19 20ths. Alright, now it's time for you to check this one out on your own. When you are done, you can come back to the video, but for now, please press pause. Alright, and we're back. Let's see what the work looks like and how the correct answer is. Alright, so we first had to change the mixed numbers to improper fractions, or just fractions. And we got 3 times 4 is 12, plus 2 is 14 in the sequence of thirds, minus 2 times 2, which is 4, plus 1, which is 5, in the sequence of halves. Do they have the same denominator? No. I only worry about the same sequence, same unit, if I'm adding or subtracting, because I have to deal on the same number line. However, I'm going to use the subtraction algorithm. 14 times 2 is 28, minus 3 times 5 is 15, all over 3 times 2, which is 6. And I know that I'm in the sequence of sixths. 28 minus 15 is 13, equaling, well, I know the numerator is greater than the denominator, so I know I'm going to have a mixed number. Therefore, take 6 sixths to make one whole. How many wholes or copies of 6 sixths can I have? I can have 2 of them with 1/6 remaining. And therefore I have 2 and 1/6. Again, you can do the division. 13 divided by 6, and you get 2 times 6, which is 12. 13 minus 12 is 1. The answer is 2 and 1/6. Either way, you'll get the answer. I hope that you enjoyed this session on subtracting fractions, decimals, and mixed numbers.